Hello everybody, let me explain about the registers of ARM processor. In ARM processor, there are two modes of operations, such as one is user mode, the other one is privileged mode. And privileged mode will have different modes of operations. So user mode will provide one set of registers which are visible generally. When processor switches from user mode to privileged mode, processor brings up those registers which were not visible in the user mode. Those registers are called as banked registers. So those registers will come into picture, that is banked register will come into picture when processor switches from user mode to the privileged mode. Let us see how the diagram of registers of ARM processor is. Here is the diagram of registers of ARM processor. As you can see here, the registers R0 to R15 and CPSR are unshaded. User and system mode will be provided with these unshaded registers. These registers will be generally visible for the user in the user mode and the system mode. That means 16 registers plus 1 CPSR register will be available in the user mode or the system mode and the system mode. R0 to R12, 13 registers are the registers which are called as general purpose registers. General purpose registers in the sense what? They will provide temporary memory, internal memory temporarily before the data are put to the ALU for addition, subtraction, etc. So R0 to R12, 13 registers are called as general purpose registers. And R13, R14, R15 are the special purpose registers, wherein R13 is called as the stack pointer which will have the addresses of stack locations. R14 is the register which will have the return address. Return address in the sense what? Many a times from the main program, processor execution might shift to a subroutine. After finishing of the subroutine, processor execution has to return to the main program. Where to return? Wherever earlier it had branched out from main program, it has to return there. So it is required that the return address of the main program has to be saved. That is saved in the link register. Then R15, which is a program counter, which will have the addresses of the subsequent instructions in a program. That means in the path of execution, whichever the next instruction is, that is pointed by the program counter in the execution of a program. Then there is current program status register. This indicates the flag conditions or flag status of the program which is currently being executed. What is the sign bit, what is the parity bit, what is the overflow flag bit, etc. will be shown in the CPSR or current program status register, which can be explained later on. So totally 16 plus 1 unshaded registers will be available in the user or the system mode and the system mode, because user and system modes are different. Then these shaded registers, what you can see are the registers which are called as banked registers. Then there are shaded SPSR registers you can see here. That means whenever processor shifts from the execution of main program to the interrupt subroutine or interrupt mode or to an exception mode. Exception mode in the sense what? It is the error condition which has to be attended by entering a mode. Like that interrupts in the sense what? Some devices want to communicate through interrupt mode of communication, in which case processor shifts to the user mode to the interrupt mode. So interrupt mode and some exception modes are the privileged mode. User mode is the general mode, normal mode, and the other exception modes and interrupt modes are called as privileged modes. So these shaded registers, about 7 registers, will be made available when processor shifts to a fast interrupt request mode. Then there is shaded SPSR also coming along with this, in which case current program status content will be saved into the SPSR of fast interrupt request, so that once you save from CPSR to SPSR, CPSR will be freely available for the use in fast interrupt request privileged mode. Likewise, from user mode, processor can shift to IRQ mode, it can shift to supervisor mode, it can shift to undefined mode, or it can shift to abort mode also. Whereas undefined and abort mode are exception modes, supervisor mode is a different one, whereas fast interrupt and interrupt request are the interrupt mode. So all the privileged modes provide different SPSR, so that CPSR will be saved into respective SPSR and CPSR will be thereby free to be used in either fast interrupt, interrupt request, or supervisor mode, undefined mode, or abort mode. That means privileged, any one of the modes can use CPSR freely, because CPSR would have been saved in the respective SPSR. So there are 16 plus 1 user mode registers. Then there are banked registers such as 8 plus 3 11, 11 plus 3 14, 17 and 20. 20 banked register will be available in the processor for the privileged mode, and 16 plus 1, 17 registers will be available for the user mode. So 17 plus 20, 37 registers will be there, though only 17 will be visible for the user and remaining 20 will be made available in the privileged mode. Thank you so much for listening to the explanation of ARM processor.